Hi, this is John-Michael Colef doing problem 2 of homework 4. So problem 2, first part, asks us to draw g of x correctly. So it gives us the parameters for g of x and we have to draw it. So for x less than 0, we just get y equals 1. So we have just 1. By the way, this is y. This is x. For x between 0 and 1, we get 0. So it just goes like this so far. Now, for between 1 and 2, we have negative x. So it's just like the line y equals negative x, except only from 1 to 2. So it's going to look something like this, and it'll be like piecewise. And then for x greater than 2, we have, stays at negative 2. So this is part 1. So y equals g of x. Alright. Now, the next part wants us to draw big F of y and little f of y in terms of the little f of x here and the big F of x, which we can sort of figure out what it looks like from this guy. So, to start, let's take a look at the mapping from x to y. So, this is just a way it helps me with the figure out the mapping. Okay. So, for the x points from 0 to negative infinity, so from here onward, these points are going to be mapped to what? Y equal 1. So all of these are going to be mapped to y equals 1. So what does that mean? We have a whole region here that's mapped to a single point in y. That's going to become a delta function in little f of y. Now, from x equals 0 to 1, this region over here, let me draw it like this, so it looks a little different. That region is going to be mapped to y equals 0. So we have this region here, this is 1. It's going to be mapped to, again, we have another impulse there. And from 2 all the way to positive infinity, this guy is going to be mapped to y equals negative 2. The region, now I can use a different pen, colored pen. The region from 1 to 2, for x, this region, that is going to be mapped to the region negative 1 to negative 2. So because we're mapping a region to a region, it's not going to be an impulse. But all these 3 pieces are going to be impulses. So, now that we know that we have 3 impulses, the next natural question will be to ask what will be their weight or their area. So, let's find that out. For the impulse at negative 2, we need to find its weight. So, impulse at y equals negative 2. How do we find the area of that impulse? Well, we take the probability of y being negative 2. Well, y is negative 2 when x is greater than or equal to 2. So it's the same thing as saying the probability of x being greater than or equal to 2, which is the same thing as 1 minus probability x random variable less than or equal to 2. And this guy is just going to be 1 minus big F of x of 2. Now we have impulse at y equals 0. Same thing. Probability of y random variable equal to 0 is the same thing as the probability of x being in between 0 and 1. And what's that going to be? That's just going to be big F of x of 1 minus big F of x of 0. Now, I need to find the weight of the third impulse. Impulse at y equals 1. Same thing. Probability, y random variable equal 1. When does that happen? When x is less than or equal to 0. So this is the same thing as saying the probability of x being less than or equal to 0. And this is just equal to big F of x of 0. So in order to get an idea of what these areas look like, we need to sort of get an idea of what big F of x looks like. So first, let's draw here. I'm just going to copy this figure for little f of x. So it looks something like this, more or less. This is little f of x. Now big F of x is just the integral of this guy. So if we're integrating this area, it's increasing. Here it reaches a peak. And as we keep going this way, the integral increases slowly but converges to 1. So here it's going to look something like this. Reaches a peak, and then it slowly converges to 1. So this is big F of x, more or less. Okay. So now let's try to draw little f of y. So this is little f of y. Alright, so again we have 3 impulses. Let's start with the impulse at 1. That's at f of x, a big F of x of 0. So it's going to be some height, like over here, something like this, and this is going to be big F of x of 0. That's the weight. The impulse at y equals 0 is going to be this difference. So it's going to look something like this, something like this. Again, we're not totally sure about the heights and everything because we don't have any numbers for these guys. These are just sketches. And finally, we have our impulse at -2. And that got, by the way, these heights, as I said, we're not sure exactly the heights, so they're sort of iffy. The weight of this guy is 1 minus big F of x of 2. It's the weight of that guy. Now, to find the for the region where this blue region for x points 1 to 2 mapping to y points -1, -2, to find out what that looks like, we use the fundamental theorem. So this is for y between -2 and -1. We use little f of y is going to be equal to little f of x over g prime of x absolute value. So, in this region, y is equal to -x. So the derivative is just going to be -1, but we take absolute value, so it's just going to be 1. And on the top, we're going to be evaluating f of x at -y. So, what does that mean? Let's take a look here at this figure over here. Say 1 is somewhere over here, and 2 is somewhere over here, right? So we have some sort of curve like this. Now we know that we want from here to here to look something like this. However, we have to be careful, because 1 maps to -1. And 2 maps to -2. So it's going to be the mirror image of this curve, right? Because if we have, if we have, I'm just drawing this here, just for reference. Let me use a pencil so I can erase it. So this point 1 maps to -1. This point 2 maps to to minus 2, but it has the same shape, so it goes up like this. That's what it's going to look like over here. It's going to go up something like this, go back down, and then we have our two impulses. So this is little f of y. Now, to find a big F of y, we have to integrate this guy. So, big F of y. So, here we have 1, 2, negative 1, negative 2, 1, 2, negative 1, negative 2. So at negative 2, we have an impulse shoots up from negative 2 to negative 1. We have some area that we're integrating. It's going to look something like this. Then here it goes down to 0, so we're adding 0 area until we get to 0. So it's going to look like something like this. Then we have a jump up. The jump, by the way, is the height of the jump is the area of the delta function. So we have a jump. Then until we get to 1, no addition. Then we have a jump. And it's just going to stay constant after that. This is going to be 1 over here. Okay? So this height is the height of the delta function. I mean the area of the delta function at 1. So it's going to be big F of x of 0. That height. This height here is going to be big F of x of 1 minus big F of x of 0. And this height over here is going to be 1 minus big F of x of 2. And this is y. And this is what big F of y will look like. And it completes the problem.